Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone. I'm Charat Ranganathan. I'm the CTO of CoreStory, and I'm here today to talk to you about how you can reestablish trust in your AI agent. In today's session, I'm going to walk you through a few things. We'll start with understanding why it is hard for enterprise IT to trust the AI SDLC. We'll talk about a solution that CoreStory has built to provide persistent intelligence that's grounded in application evidence. We'll explore how it works, what it gets you, and we'll look at some evidence as to how this solution has helped in the industry. And finally, we'll wrap up with some discussion, obviously with Q&A and anything else. While I'm talking, please feel free to put your comments in the chat, and I will get to them at the end of the session. All right, so let's dive in to how we establish trust in the AI SDLC. And why is AI usage fairly ubiquitous, actually, but at the same time, enterprise IT managers are actually quite uncomfortable with it. We all know that AI is an accelerant and that AI engineering is no longer optional. We have seen the promise of being able to move faster with less effort. We have seen how enterprises expect AI to speed up modernization, reduce maintenance toil, raise delivery throughput. Now, all of this is great, but the biggest challenge that AI agents have in making this promise a reality is that they really need to understand the system for which they're generating code or the system that they're maintaining. And this skepticism is quite easily earned because people have seen the large volume of code that AI agents can generate. But very often you will hear senior engineers saying things like what you see on the screen, which is that they don't trust the code that AI agents wrote because the code is never actually understood. And it's important to think about that last part of this phrase because while the volume of code, the sheer volume of code is almost unbelievable at this point, the AI agent never understands the code, nor is it able to explain what the code does in terms that business people understand. So there's this problem that is associated with sort of the developer side of the world, right? 96% of developers, based on a Sonar survey, 96% of developers don't fully trust that the AI-generated code is functionally correct. And yet, only 48% of them actually check it before committing. So you've now got this dichotomy where you have a huge volume of code being produced, but not all of it's actually being tested or not all of it is being checked before it gets committed into a code base. And so that causes one set of problems and it aggravates or exacerbates the distrust in the AI SDLC. On the other side, you have the reality of the estate in the enterprise, which looks like, it's a single estate, like how complex could it be? But the reality is that enterprise estates are exceedingly complex. They are heterogeneous, meaning that they often have multiple languages. They may have applications written in COBOL or Java or .NET, different versions of Java or .NET or even COBOL. They may be using SaaS products. They may be using COTS, commercially off-the-shelf products, or customizable off-the-shelf products. And many of them are often tied together by scripts or things like that because not everything has a clean API. These systems are often very interconnected. It's not like every application in the enterprise is an island. There are applications that have to talk to each other, right? As an example, your CRM system probably needs access to ERP for order status. Your ERP system itself might need access to the FMS in order to understand where a particular part is that is being produced or what the status of that part is. And all of this, the data is being exchanged not always through clean APIs like modern applications or contemporary applications. The data is often being exchanged through batch files, batch jobs, queues, even just simple file transfer where you throw a file into one location and another job picks it up and moves it to the other system. But the fact is that all these applications are extremely interconnected. And these applications are also evolving. It's a misstatement to assume that even legacy applications are in a state of suspended animation. In fact, many business applications, many legacy applications are still evolving to meet the evolving needs of the business that they support. And so you've got the second set of issues in the enterprise. And when AI agents encounter these issues, they often have 4 failure modes, or they exhibit sort of 4 typical failures because of the nature of the beast, because of the nature of what AI agents are. The first is that AI agents have no persistent semantic model. They rediscover the repository on every request. You've seen this. You go into Claude Code or Codex or your agent of choice, and you notice that every time you ask it a question, it's off doing a bunch of greps and finds and searches. And then it sort of consolidates all that information while burning a bunch of tokens to give you an answer. And that answer is functionally very accurate, but it's not semantic, right? And it's not persistent. So the moment you kill your agent, the next session starts afresh. Sure, you have some level of memory, you can write to markdown files and all of that, but it's not the same as having sort of a persistent semantic model. The business meaning is unobvious. Yeah. So these code agents are really good at explaining what code does. They're really good at telling you how the code behaves. They can go right into a single function and tell you exactly what that function does. But in order to express that in terms that the business understands is really hard for them to do. They can tell you that a function adds 2 numbers and has a rate input and a number of iterations, and it can tell you it does all of that. But it probably won't be able to tell you that's actually a function that is calculating compound interest. And that's what I mean by business meaning being unobvious. There is no shared truth. AI agents are repository level solutions. So each agent is forming a local understanding of the code base, but the team as a whole doesn't have a shared understanding of the code base because one really doesn't exist. You can fake it with things like artifacts or little websites that they create. You can create your own markdown files, but the fact is that there is no shared understanding there. And finally, the understanding stops at the repository boundary. Because the tool by itself is a repository level tool, unless you consolidate everything into one repository or something like that, it's almost impossible for these tools to understand what happens outside of the repository boundary. And so the result of all of this is you have fast answers, but they're built on temporary, local, and incomplete context. But what do teams actually need? Enterprise teams need a system of record for the entire enterprise IT estate. They need solutions. They need a source of context that is persistent, shared, evergreen, and grounded, meaning that they need something that can survive a single prompt or an agent session. The entire team needs to be viewing the application or the applications for which they are responsible from a single pane of glass or a single window. They need to have the same understanding. The PM, the business analyst, the developer, they all need to be seeing the application the same way in order to have that shared understanding. The understanding needs to be evergreen meaning that as the application is updated, as it evolves, and as its dependencies change, the underlying knowledge of the application changes or evolves along with it. And finally, and perhaps most importantly, you need to have these answers that are grounded in the source code evidence, meaning that when you say that this application calculates compound interest, you need to be able to go from that business statement all the way down to the source code from which that statement was created or was derived. Once you do that, once you have that level of grounding and traceability, you automatically have a certain degree of trust that is established in the process. And it's obvious because today that's kind of what we do, right? Like when we build applications manually, the old-fashioned way, I guess, that's what we do. We understand what happens to the application. We translate requirements that are expressed in business terms all the way down to source code. And we're able to make that tie-in between the two, perhaps through a series of documents and Jira tickets or linear tickets or whatever. But that's how those connections are made. So what is the solution to this sort of this almost this fog of despair that exists, right? Like you've got this need to move fast, but at the same time, you don't trust that you can move fast and not trip over yourself. So what's the solution to this? The solution to this is a persistent, evergreen intelligence layer, which CoreStory provides. We ingest the full repository, we ingest documentation, we ingest all of the context surrounding an enterprise application, and we build structured, queryable models of how the system works. We look at the architecture, the workflows, the business rules, the dependencies, and we don't just guess this from just-in-time file scans every time you ask a question. We store that as a persistent storage that you can then query over a web interface, or if you're using an agent, you can look at it over MCP or an API. MCP, obviously, the most preferred mechanism today. Not only does CoreStory create this persistent intelligence model, it also, as I said, can project the data into both the technical domain as well as the business domain. So we can go from source repository, CI/CD, IAC, documentation, and so on, to everything from architecture, code behavior, dependencies, which I consider to be technical domain, to the business domain, capabilities, functionality, actors, business concepts. And so the same grounded model is now serving not just a developer or not just one constituency in your enterprise IT team. It is serving multiple constituencies, developers, architects, product teams, and AI agents. And I was once talking to a CIO, and the way they put it was actually very, very nice. They basically said, oh, so CoreStory becomes almost a single sandbox from which all these different enterprise teams can sort of share information and share context, and that is what we do. So all this is fine and dandy, right? Like all this is really cool. Let's kind of think about how this works and how does CoreStory establish that trust back into the AI SDLC. So we have a 4-step process to extract intelligence that is grounded. We start with exploration, ingestion, projection, and certification. If you talk to someone at CoreStory, and we really hope you do after listening to this talk, you will often hear people calling these the 4 pillars as well, but that's what they mean. It's a 4-step process in which grounded intelligence, persistent grounded intelligence, is extracted from a code base and from documentation and everything else that surrounds it. So we start with exploring the code base, just building a dossier of the code base. What are the files in there? What are the directories? How is it laid out? Do any readmes exist? What languages exist within the code base? What frameworks, and so on and so forth, exploration phase. And at that point, we launch what we call polymorphic agents. We'll talk about what polymorphic agents are in just a second. Once we've launched the agent starts to build, or the agents start to build an ontology-backed graph and a vector representation, a simple intelligence model, a base model. Once that's done, we have a set of agents that project that data into business meaning. So they take code behavior, code interrelationships, and they start combining them and abstracting them into business behavior. Remember that the higher or the further away you get from code towards the business, you are basically going through a repeated process of abstraction. And that's what the projection step does. It combines different elements of code, it identifies common behavior, and then it expresses that in terms that the business understands. Finally, and perhaps most importantly, we certify all of those outputs and preserve evidence. There is traceability that is inherent in the mechanisms that we use, and we'll talk about that. And then we also have something we call a trust engine that essentially provides you with an overall measure of how much you can trust the outputs that are produced. All right. So let's talk a bit about polymorphic agents because we talked about it quite a bit. And this is really cool technology. Polymorphic agents are AI agents that dynamically adapt their reasoning strategies, their tool selections, analysis techniques based on the language, the structure, and the context that they encounter. So they exhibit three characteristics. They exhibit language-aware reasoning, meaning that they can identify the language, the dialects, and even the era of code. Based on that, they can use a set of tools and select them dynamically. So rather than saying, I have built a COBOL parser, they can decide and say, oh, this looks like COBOL, so I'm going to basically use a parser for COBOL because I have one. But then, oh, that COBOL file now calls, say, PL1 through some kind of a JCL, and I don't have a parser for JCL or PL1, they can immediately go off and use inference to understand what the PL1 code is doing, and then how the JCL is calling that PL1. And so they exhibit both dynamic tool selection as well as this cross-language context fusion, meaning that they can operate across languages and no longer are you restricted by a tool that is built just for one language or a couple of languages. It's actually, it is actually able to span multiple languages. And so when a polymorphic agent encounters a code base, it then identifies the languages, the dialects, and so on. It selects and chooses a strategy to execute. It then uses that strategy to analyze the code base, and it then synthesizes all of that data into unified context. All right, so that's the exploration phase in a nutshell, right? A set of polymorphic agents that go through a code base, that build a plan to analyze the code base, and then go execute that plan. And to be clear, a lot of this also happens with static code analysis. So that is just one more tool in the toolbox. So it doesn't all have to be inference. And so it can actually occur really fast as long as you have the right parser for that specific language. Once we're done with the exploration phase and the ingestion has proceeded, the output of the ingestion phase is this base model. The polymorphic agents create both the knowledge graph as well as the vector store. And the knowledge graph is grounded, and we'll see the ontology that we use in the next slide. But the knowledge graph is grounded in the code and then projected all the way to the business domain. And so what you have at the output of this ingestion stage is code level truth that is structured, persistent, traceable, and queryable. So we have been talking about this ontology. So what is this ontology all about, right? The ontology is a 6-layer ontology. It is something that we have created here at CoreStory. We call it the SAO, the Software Application Ontology. I obviously need to get marketing involved in this because they probably come up with a more creative name than Software Application Ontology, but we'll get to that in a moment. So the ontology itself, as I said, has 6 layers. And if you see, code structure is basically at layer 3. And from there, we start to derive more abstract objects. So we go from things like code containers and callable units and data structures to systems and modules and services and integrations, then to things like domain entities, relationships, all the way to very generalized business concepts like capabilities, workflows, rules, and lifecycle. And if you look at the code structure itself, you'll notice that we don't use terms like files, directories, functions, procedures. We don't because the SAO is a generalized ontology that is supposed to work across multiple languages and multiple frameworks. And so to use terms like, say, a function would be restricting yourself, right? Because COBOL calls, in COBOL, something that you can call is called a procedure. In Java, it's a method. In Rust or Python, they're functions. And so we generalize all of them and group them into what we call callable units. And callable units exist in containers of code, files mostly, right? So we call them code containers as opposed to calling them files or directories, because they may be called files in some place, they may be called a module in another language. They could be called directories or folders or whatever. So you get the point, though. The whole idea is generalize everything so that you can express any language, any framework in terms that are generally understandable by everyone, including the models that we use. Now, once we've extracted this ontology through the projection phase, once we have gone from code structure to architecture to domain model to business intent, we now have a view of the code base that can start from business intent, but is actually traceable all the way down to the code structure and the actual units of code that produced that capability or that functionality, right? So that is the really cool part of all of this. And that traceability is what enables us to reestablish trust in the AI SDLC. Not only do we have traceability, we also have a separate trust engine that we execute after every ingestion. The trust engine is a piece of software that we've built that analyzes the outputs that CoreStory produces. So it analyzes the outputs that come out of the intelligence model and scores them across 4 dimensions: accuracy, completeness, traceability, and usefulness. And these are all weighted, as you can see. So, a 30% weightage for accuracy, which we obviously want, the highest weightage. Completeness and traceability, 25 each. And then usefulness is at 20 points, because usefulness is a very subjective measure. And what the trust engine does is it looks at a code base, it generates a set of synthetic questions and synthetic golden answers based on the ground truth in that code base. It then asks CoreStory all the questions that it needs to ask. So those synthesized questions are asked of CoreStory. The signals that are produced from CoreStory are then judged and scored through 2 independent models. So there's dual model consensus there. We currently use Codex and Claude Code, but we could use any other set of models as well. Using this 4-dimension rubric, we score the outputs, and then we use that to certify the outputs. And it generates a binary score. So it says whether something is certified or not, and we've got a cutoff there. So trust in the SDLC, trust in the intelligence model, is established in 2 ways. The first being traceability, the second being the trust engine. Finally, and this is a piece that is not part of the 4 steps, but once the intelligence model is created, we want to create an evergreen model of the code base. As I said, the code base evolves over time, and we need to be able to create this evergreen model. And what we've built is something that we call living intelligence, where the code base is constantly being re-explored. It's actually triggered. So, a new commit will trigger a re-exploration. We detect just the deltas that have changed. We use that to incrementally re-ingest. So you're not burning tokens by some crazy re-exploration of the entire code base. You're only incrementally re-ingesting the code base. You're using that to re-extract and refresh all of the abstractions. And finally, you recertify the model by regrounding the answers. So you repeat this on every meaningful change. And now all of a sudden, what you have is this evergreen application intelligence. So what's the net result of all of this, right? So all of this sounds cool. It's a lot of stuff, a lot of terms that I threw at you. So what is the net of all of this? The net of all of this is that you can answer complex business questions without just-in-time repository grepping in a manner which is trustworthy, because you can trace from the code base, from the answer all the way down to the code base. And so, we've sold to different enterprises, and one of them is a life insurance company, and they have, they typically get asked questions like this. Can we offer a policy that pays a defined amount plus all premiums paid so far? Very business question. It's something that a business analyst would probably ask. The CoreStory system interprets that question. It recognizes that this is a question about death benefit options, which is a thing, by the way, in the life insurance industry, if any of you is from there. It identifies that this maps to something called a return of premium or death benefit option 3. It then validates the implementation, the code base. It uses the intelligence model to validate whether that is implemented in the code base, and finally returns a response that is linked to the source file. And so we can basically say, yes, the system offers, what you're asking is death benefit option 3. Yes, the system implements DBO3, and DBO3 exists in these code files, in these functions, these procedures, whatever. And so that traceability is now changing the way you view the outputs. You're no longer looking at the outputs you're no longer questioning the outputs, because you can actually trace all the way from the level 6 SAO ontology, the business intent, all the way down to code structure and eventually source code. So you can go from 6543 down to the source code because the ontology and the knowledge graph that is built using that ontology is grounding the answers that you have. And so if you think about this, this is the way you reestablish trust in your AI SDLC. You use traceability and the trust engine in a persistent, evergreen knowledge base to answer questions about your code base. And so let's look at some evidence, right? So we did a joint study with Microsoft, and what we found is that 51% more GitHub Copilot suggestions were accepted by developers when Copilot was used with CoreStory or grounded by CoreStory, as opposed to when it wasn't. So 27% to 41% increase in acceptance rate. We found that the use of CoreStory in conjunction with an agent, and we actually have a set of skills that go with all of these agents, we found that when you do this, you basically get 44% better task resolution on benchmark evals, almost 25% higher task completion versus the control. So the task completion rates in standard benchmarks increases by about 25%. And we can ingest huge numbers of lines in minutes because, like I said, the polymorphic agent can decide. And in many cases, if a parser exists for the code base, we actually will resort to static code analysis as opposed to going through and using the LLM for inference and inferential analysis, which is obviously much slower, burns a lot more tokens, and so on and so forth. So that's the evidence that we can present to you. And so, kind of wrapping up, the three things to remember, three takeaways from this. The skepticism about the ability of AI agents or the code quality generated by AI agents is right, because without context, agents are merely guessing, is the way to look at it. Verification is the bottleneck, right? You don't have time to verify the huge volumes of data or code that are generated by agents. And the only way you can close the gap on verification is by grounding traceability and not by just having willpower or more people. Like, you can't throw more people at this problem. Well, you could, but it's probably going to cost you more and it's probably not worth it at that point. And this trust that you have in the SDLC is earned, never mandated. So it's not going to be possible for an enterprise IT manager or a manager to basically say, hey, you know what, just use Cloud Code because I trust it. Well, that's not going to work, because developers are going to be rightly suspect of what they see. And so you give the engineer this grounded, reviewable agent, and they'll use it without being told to. So these three big takeaways. And so I'm going to just put some questions up just to start triggering your ideas on what questions you want to ask. But we have more than 15 minutes at this point. So bring your questions. I'm happy to answer them. And while we wait for questions, please also remember you can go to app.corestory.ai. You can point CoreStory at a repository, see what it extracts. You can also talk to an expert. So you can go to corestory.ai/contact, call one of our experts, and we will be happy to talk to you about it. So I'm going to pause here. And since I don't have access to the questions, if one of the moderators could please maybe ask me the questions, I would love to answer them. Or maybe what I'll do is I'll hide my screen, my sharing, and then we'll go back here and stop sharing. There we go. Wow. What's your favorite language and why is it Rust? It is not Rust, but Rust has been, it's a really cool language, by the way. And we actually ended up writing some parts of our platform in Rust. Any other questions? So maybe I'll ask a few questions because, just to trigger. So one of the questions we often get asked is, does it work with our stack? We've got COBOL, we've got Java or .NET, and the answer is yes. Because we use a polymorphic agent topology, we're able to analyze applications and languages where we may not have a parser available, and we're able to actually use that information through the ontology to actually give you very grounded answers as well. And how do you know that the specs are right? It's basically through the trust engine itself and the traceability that we have. Right. I guess if there are no other, sure. A question here. How does this improve verification compared to just using Claude with information about the business logic in .Claude? As I mentioned, even if you have business logic that is stored in your .Claude files or your Claude.md or even a set of wiki pages, what you don't get very easily is the traceability all the way down to source code from the business domain all the way down. And that's the piece that CoreStory really does well. So that's how we improve verification, or that's how we verify that the results that we generate are accurate. So it's this combination of traceability along with the trust engine that gives you that. And you can't do that easily with just a .plot file. Sure. So the trust engine, so the question in chat was, can you explain what the trust engine is again? And the trust engine is something that we built. Essentially what it's doing is it's using a combination of synthetic questions that are tied to a code base, asked against the CoreStory engine, and then an LLM as a judge that grades the resultant answers across 4 dimensions: accuracy, completeness, usability or usefulness, and there's a 4th one, which obviously my brain doesn't comprehend right now, but it's traceability. So we essentially built this engine that runs across. Once we've generated the intelligence model, we run across that. Yeah. And yes, as someone said in chat, explainability is essential, and that's what we're going for, right? So we have traceability as well as an analysis of the answers that we generate and graded against these other dimensions of accuracy or completeness. All right. So if there are no other questions, I guess we could shut down then. Please come and talk to us at CoreStory. Please contact us. You can reach out to me on LinkedIn. My name is not that hard to find. So please do reach out, and we are happy to talk to you. I'm happy to talk to you more about the solution that we've built. Happy to talk about AI SDLC and how we reestablish trust and things like that. Look forward to continuing this conversation. Thank you.
Thank you all for joining, and thanks again to our speakers. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find our survey link on the screen or in the chat, and we'll see you at the next one.